Lesson 17 has 3 parts. The first 2 parts are just learning us some definitions, dealing with factors and coefficients and terms. And then the third part will be working some problems that deal with the distributive property. Now in Part A, some of this we've already had to understand, especially when we're doing evaluations of expressions. And for example, let's look at the circumference of a circle. That's equal to 2 times pi times the radius. Now, we could also just say that 2 pi r, but we know already that each of those parts or factors, we're all multiplying those together. We're doing 2 times pi times r. In the same way, this expression here, 3xy, we are saying 3 times x times y. So those are things you probably already know. If you don't know them, it's really important that you figure that out real soon. That when you see relationships like that, where you have symbols and numbers, especially like a number right after a symbol or right before a symbol, that indicates multiplication. Now there's also an X symbol that represents multiplication, right? So you probably won't be seeing that quite as often anymore. And you may be seeing like 3 times 2 like that, a little dot. And in algebra, a lot of times they do that just so you don't think that you really have a variable there and you're saying like 3xy or something like that, or 3x2. And that really means 3 times 2. So probably a lot more from now on you'll see a dot instead of an X symbol there for multiplication. Now a coefficient, that's basically just a part of one of these expressions, and they have literal coefficients or letters that are coefficients, but almost always when you talk about coefficients you're talking about the number or the numerical coefficient. Like in 3xy, the coefficient there is a 3. So sometimes they talk about it as a letter or a literal coefficient, but for the most part it's a number that you're considering when you hear the word coefficient. So coefficient, that's just a word that you'll hear from time to time, and almost always, like I said, that will be concerning the number in an expression, and the number is usually the first part of an algebraic expression. Now terms, I have this definition written here that they are a single entity that has or represents the value of one particular number. For example, all those evaluate problems that we've been doing, you could think of those as terms because we get one answer for each one, or one particular number they represent. For example, this expression that I have written here, there are 3 terms that we consider there. The x could be considered a term because that is a single entity, it's a single thing that has or represents the value of one particular number. And then the 3ab, and we would include the sign in front of it, so the plus 3ab, that is considered a term. It's a positive 3ab, and that could represent the value of one particular number. And then the plus 2xy over z, we would consider that a term as well. And we include the sign in front of it because we think of algebraic addition, and that's where we add negative numbers. So if I would have had x minus 3ab, we would have considered that second term to be a minus 3ab. Understanding what terms are, that'll be important in some later lessons, and we'll be doing some applications with terms. And in fact, lesson 18 will be using them. So right now we're just getting introduced to them. Part C is about the distributive property, and we will also just be introducing this concept right now, just like we did terms, and we'll be applying these ideas in later lessons. Now the distributive property is basically an expression like this: A times B plus C. Think about the words here, distributive property. So it's a property of distribution, and basically what we're doing here is, if you saw that expression, the first thing you would think was, okay, I need to do the operation inside the parentheses first. So I would do that addition of B plus C, then I would multiply by A. The distributive property is a little bit different than that, and that can be a little confusing because we kind of have to learn a new way of thinking about a problem like this. there's another way to do this problem. We can distribute that A, basically, over B and C, and we do that by multiplying. And we can say A times B plus A times C. So we've distributed the A over B plus C. If I had this problem right here, 2 times 3 plus 4, I could do it like I've been doing problems, where we would work the inside of the parentheses first. We would do addition first, and so that would give us 2 times 7, which equals 14. Or we could use the distributive property and distribute the 2 over the 3 and the 4. And in other words, we would do multiplication first. We do 2 times 3 plus 2 times 4. And as long as we do everything right, we get the same answer. 6 plus 8 is 14. So the distributive property, that is basically multiplication first on a problem like that, instead of doing addition first. Now, the distributive property, that can be extended to more than just 2 variables on the inside of the parentheses. We could have A times B plus C plus D plus E plus so on. There's an infinite number of variables that could be on the inside there added together. Just showing A times B plus C, that's just good for understanding the distributive property, but it can be extended to a multiple number of add-ins inside the parentheses. Now, the distributive property can be applied to do problems where they tell you to expand this expression out. For example, look at practice problem A. We can't simplify that. We can't simplify 3 plus BC on the inside of those parentheses. But we could use the distributive property and expand that problem. We could take 2a and multiply it by 3, and then take 2a and multiply it by bc. So let's just go ahead and do that. So we'd have 2a times 3 plus 2a times bc, or we can just write 2a bc. Now usually what we do when we have a couple of numbers, like in that first term there, we would multiply the 2 times the 3, because remember, order does not matter in multiplication. We can say 2 times 3 times a, or 2 times a times 3. And it just looks a little bit neater, and it makes it a more simplified form if we do the multiplication of those numbers. And so we'll have 6a plus 2a bc. And so that would be the expanded form of that expression. So you'll be having some problems where you see that word expand above the set of expressions. Anytime you see that, that means you need to use the distributive property, and you do multiplication first. You take the term on the outside of the parentheses and you multiply it, the first term on the inside, then you multiply the second term on the inside. And then if there's a third and a fourth and a fifth term and so on, you multiply the outside term by those as well. Look at practice problem B. Let's go ahead and expand that expression as well. So we have 3x on the outside. Let's multiply that by the a. 3x times a. And then we have 3x times a negative b. And so we can put the negative in front and just say minus 3xb. Now, if you looked in the solutions manual and it said minus 3bx instead of minus 3xb, that's not wrong, because remember, order in multiplication does not matter. And so let's go on to the last term here. We multiply 3x times 4, and we would have 12x. That's a real important thing when we're doing these expansion problems, is for you to know that the order does not matter in multiplication. For that last one, we could have had 3x4, but we don't want to write it like that. We want to multiply the two numerical parts together by just rearranging and saying 4 times 3 times x. And so that would equal 12x. And so 3xa minus 3xb plus 12x, that's our answer. Let's do one more. 4xy times ac minus 7. So let's expand this problem. That's what we're doing. We're going to use the distributive property, and we'll distribute 4xy over the AC and the negative 7. So we do 4xy times AC, and I just like to do these in alphabetical order. It doesn't really matter because the order in multiplication doesn't matter, but I'll make that 4ACXY. And then 4xy times a negative 7, I'll put the minus sign in front and do 4 times 7 is 28xy. If it helps you understand these, you can slow this process down a little bit, do a couple more steps, and just think of 4xy. I'm multiplying that by AC first, so I'll just say AC in parentheses, and then plus 4xy times the negative 7. And then you can just rearrange. I mean, you really don't have to, but you normally, when you have a bunch of variables or letters, you don't have parentheses there. You don't keep the parentheses there. And so you can rearrange it 4ACXY. And then 4 times a negative 7, that's negative 28. And so we'd have plus a negative 28, or just erase the plus sign and put minus 28xy. I'm going to do a couple more of these problems because I found that students tend to get stuck on these, and I want to try to help you understand this as good as you can before you go on to the problem set. So let's do another one of these, and let's expand this relationship here. And we see that we have ABC, and then on the inside negative 3y minus 2f. So let's just go ahead and do that multiplication of ABC times negative 3y. We'll do that first. And then let's put a plus sign here, and now we'll do ABC times negative 2f. So we write that out. Now, let's go ahead and look at that. ABC times negative 3y. Remember, the order doesn't matter in multiplication. So that negative 3, that's a factor in there, and we can move that negative 3 to the front, because usually that's what we do with the numbers in a term. The numerical part, we put that first, and then we say A, B, C, Y. Now we don't have to put the number in front, but that's usually just kind of the standard accepted way to do those problems. And then for the next one, let's put the negative 2 in front. Instead of saying plus a negative 2, we'll just say negative 2 A, B, C, F. And so that would be our expanded form for that expression. Let's do one more. We have negative xy, and then on the inside of the parentheses 4 plus a plus cd. So let's go ahead and do the expansion here. Negative xy times 4. And then we'll put a plus sign here. And then we're going to do negative xy times a, and so we can just say negative xy a. And then we'll put another plus sign, and then we have negative xy times cd, so we could just say negative xy cd. Put that in parentheses. Okay, now let's go ahead and just rearrange some things here to organize it a little better, and we'd have minus 4 xy minus AXY. I just like to put the letters in alphabetical order. You don't have to do it that way, but I just like to do it just to keep things a little more organized. And then minus CDXY. So that's the expanded form of that expression. It has 3 terms in it. Remember, terms, those represent or have the value of a particular number. Okay, well that's all for lesson 17.